Hello everyone. So in this video I am going to solve question number 45 of GATE 2020 physics question. So let's solve the question. For a one-dimensional harmonic oscillator, the creation operator A dagger acting on the nth state psi n, where n equal to 0, 1, 2 dot dot dot, gives A dagger psi n equal to root over of n plus 1 psi n plus 1. Then the matrix representation of the position operator X equal to root over of h bar by 2m omega A plus A dagger for the first three rows and column is given by this four option. One of these four options will be correct option. So let's solve this question. Yeah. So A dagger n equal to root over of n plus 1 n plus 1. I have written psi n plus 1 as n plus 1. Just for convenience. So, and the annihilation operator acting on n will give us root over n and n minus 1 state. The position operator is given by h bar by twice m omega and a plus a dagger. What I need to calculate is the matrix representation of x, and which is given by x00, x01, x02, x10, x11, x12, x20, x21 and x22. This is the matrix representation because n start from 0 and it goes to 1, 2 like this integer values. So for the first three rows and columns the matrix will look like this given matrix, this matrix, where each element of x, like if I take a element this will be given by, this is just xnm, so each of this element will be given by this, like x00 is just this element. So let's first calculate this first element of this matrix, which will be h bar by twice m omega and 0, a plus a dagger 0. Now this constant term will be there, and a operator acting on 0th state will give us just give us 0, because this annihilation operator acting on this ground state gives us 0, and a dagger acting on 0 will give us this. Now the orthonormality property is m n equal to delta nm. So if m not equal to n, then this is just 0. So this is just 0. So the diagonal element, the first diagonal element is 0, and similarly we can show that all the diagonal elements are 0. This equal to 2 is 0. So option A and D are ruled out because here all the diagonal elements are not 0. So we are left with only option B and option C. Since this term and these terms are equal, let's compare this term, because this term different in these two options, that is x12. So x12 is 1, x2, and this is given by h bar by twice m omega, the constant part, 1 a plus a dagger this state. So this will give us 2 to the power of h bar by twice m omega, and this state acting on this will give us root 2 and the state 2, sorry, the state 1, plus a dagger acting on this will give us some constant into this state. Since 1 and 3 are not equal, then this will give us just 0, so this term will not contribute, so we will left with only this term, because a acting on 2 is root 2 state 1, and that is what we applied here. And this is just 1 because we apply this property, this orthonormality property. This is just 1. So what we get back this, so we are getting root 2 and not 1. So option C is the correct option for this question. So the correct option is option C. So this is the shortcut method to solve this question. Thank you.